Part 2 of Lesson 6, Chapter 2 is on solving rational inequalities. So you're going to be given a problem like this. It says solve each inequality. And what you're going to do is you're going to draw a sketch first of this rational function. So we'd begin with knowing where the vertical asymptotes are. On this problem, your vertical asymptote will be at x equals 3/4. So if I put in a vertical asymptote on our graph at 3/4, let's see here, our x-intercept would be at -6, and our y-intercept would be at -2. Again, how I found that y-intercept is by putting 0 in for all the x's. How I found the x-intercept is setting the numerator equal to 0. And so if we have a y-intercept at -2 and an x-intercept at -6, and we also have a horizontal asymptote at y equals 1/4, because if you divide leading coefficients, 1 divided by 4, you get 1/4. So if I put that in, our graph should look something like this. Now keep in mind that this vertical asymptote is at 3/4 and the horizontal asymptote is at 1/4. And now what they're asking us to do is tell us when it's greater than 1. So I'm going to draw a horizontal line at 1. Okay. And so when is this graph above that yellow line? This is where it's above that yellow line. So we have to give an answer on that region. So our answer is going to go from the asymptote 3/4 until we get to this coordinate point right there. So we're going to have to figure out what that coordinate point is. So to find that point, we'll use the graphing calculator. And you can see I've got the function entered, x plus 6 divided by 4x minus 3. I'm going to put a horizontal line at 1. And now I'm going to graph it. And here's the graph that we just drew. And here's the horizontal line at 1. And we're going to need to find that intersection point. Let me zoom in a little bit to get a better picture of this. Okay, this will give us a little bit better idea. And then the horizontal line at 1. Okay, so the important point is where the red and the blue line intersect. So to find that, we'll use the trace feature. And I'm going to guess it's someplace about 3. Let's just try 3. Hey, sure enough, it intersects at 3, 1. So on my solution, it's from 3/4 to 3. Now an important aspect on this is I have to put a bracket on the 3, but a parenthesis on the 3/4. The reason there's a bracket on the 3 is because look at the inequality right here. It's greater than or equal to. Thus there's a bracket. And the reason there's a parenthesis on the 3/4 is because you always put a parenthesis on an asymptote, because it never equals that particular value. It just gets closer and closer and closer to the asymptote. So this is our answer for the problem. When you're doing these, you are going to need to draw a picture like I've done and label some things like I've done over there. Let's do another example. Same directions, solve the inequality. So we're going to need to draw a picture on this. So the first thing I'll do is figure out my vertical asymptotes, which in this problem there's just one, at x equals 2. Okay. Horizontal asymptotes. They're there is a slant on this guy. So let's find that right now. We can do synthetic division on this one. And when I find my slant asymptote, you get these numbers, and we don't care about the remainder. We just care about the other digits. So my slant asymptote is y equals 1x plus 1. So if I were to draw that in, 1x plus 1, I have a y-intercept at 1, a slope of 1. So that would look something kind of like this. Okay. All right, we would have x-intercepts by setting that numerator equal to 0. Now that's not factorable, so we're going to use the quadratic formula on that in a little bit. And y-intercept, put 0 in for all your x's, and you're going to get negative 11 over negative 2, which is 5.5. Okay. So x-intercepts, let me use the quadratic formula down here on that. So it looks like we're going to get 1/2 plus or minus the square root of 45 over 2. Okay, and so that could be written as 1/2 plus or minus, that's going to be the square root of 9 times the square root of 5, which is 3 square root of 5 over 2. Okay, so there's your two x-intercepts. If we find decimal approximations with those, let's clear this away first. So 1/2 plus square root of 5, I said, right? Square root of 5, 3 square root of 5. 3 square root of 5 divided by 2. We get about 3.8. So on my graph, I'm going to go to 3.8 and make a point someplace over here. And then also, if we do the same thing but with a minus on it, press enter, we get negative 2.8. So over here at negative 2.8, we'll also have an x-intercept. And our y-intercept we said is at 5.5. So that's going to be someplace up here. So my graph should approach the asymptote and then flatten out towards that asymptote, which means on this one, I'll get closer to that asymptote. Graph kind of looks like this. Now we're going to have to put a horizontal line at 3. Okay, so if I put a horizontal line at 3, you have to tell me when is the graph below that yellow line. So we'd have all of these points, and then all of these points. So we're going to use the graphing calculator to help us find a couple of these important points, and the important points are going to be this point right here and this point right here. So we know that our answer is going to look like this. It's going to be negative infinity to whatever this point is, and we're going to need a bracket on that, unioned with, starting from the asymptote at 2 to whatever this other point is, and that's going to be a bracket on that. So we're going to have to use the calculator to find those two important points. So I've got the graph typed in, and let's graph it and see what we get. So as you can see, our graph looks pretty similar to what we had drawn. It's got a slant asymptote, it's got a vertical asymptote. There's the horizontal line at 3. So looks like maybe it's crossing at -1. So let's try that out. Sure enough, it is crossing at -1. Therefore, we'll need a -1 right here. And then over to the right, it appears to be crossing at about 1, 2, 3, 4, 5. So let's type in 5, press enter. Sure enough, it is crossing at 5. And so there's the values that are below the horizontal line at 3. Alright, so there's two examples on solving rational inequalities. You're going to be drawing pictures on these and identifying parts, and then finding where it's above or below a particular value. Homework problems you're going to be working on page 145 is 19 through 27 odd with sketches, and then 30 through 34 even. This will be collected on Wednesday.